Alright, we looked last week at finding the vertex of some parabolas. We talked about vertex form and standard form. Well, of course, we're not going to work out today. Start the day off on a good note.
Oh my lord! That's great, though. Let you know go for the day. It's gonna be that name.
I love the little noise it makes.
No, it's gonna like a good heat.
Well, I got it for change. I remind her of purchase. But then I was going to get a red one because this lady grabbed the last red one. You make me feel bad talking about how you're figuring out why you're figuring that out. I was like, that looks like a Leah.
Coach Wright, does the Z mean 0?
Yeah.
How many?
What's the next mean?
Exempt.
I don't need to exempt, I need to grade.
Yeah.
I don't know, I need the points. On 2, 3, 7, what was that?
Well, I thought we were back now.
It was.
I'm like, I was going to get you a week or something.
Yeah, it was.
Like, Saturday. I know, not Saturday, Monday.
Well, I'll get you tonight. My Valentine's Day was getting out of school. My mom said no.
She did. I was like, hey, can I give you all? She
They just messed up all your stuff, didn't they?
Great.
I'm trying to make a habit of
Hey, you had to go to stuff though. She didn't let anybody leave.
Yeah, for real. I needed to go get my makeup sheets and then someone, Bailey, or somebody else in the bathroom could give me the other. She said, no. Because my sister.
Alright, last week, shh, y'all be quiet. Last week, you already have this in your notes. We looked at the standard form of a parabola, and then we looked at vertex form. Just giving you a little bit of a reminder here. You should already have this. Okay, vertex form, we like it because it tells you the vertex. That's why it got its name, the vertex of BHK. To start finding the vertex when you're in standard form, your x coordinate was equal to the opposite of your b divided by 2 times a. Then once you get that, you would plug it back in to find the other part, the y. Okay? You should already have that, but just wanted to remind you because we're going to start off by using that standard form formula there. Okay? Everybody got what you need off of it? Alright, so if I gave us a parabola, say f of x is equal to x squared plus 4x minus 9. Directions say find the vertex of the graph. Okay, so first thing you would do is you would look at that and say, okay, that's in standard form. My A is 1, my B is 4, and my C is -9. Now, you don't have to label all that. Just want you to make sure you're familiar with where I pull these numbers from. So my x is equal to -b over 2 times a. So 4 over 2 is 2, and then negative, so my x would be -2. Okay, I'm trying to find a vertex, so it's got to be -2 comma something. So how do I find out that something that goes there?
Plug it in.
Alright, so that gets me -2 squared plus 4 times -2 minus 9, and I just work that out. -2 squared is 4. 4 times -2 is -8. So 4 minus 8 is -4. I'll get off of that in just a second and write on the board. 4 minus 8 is -4 plus 9 is 5. So our vertex would be -2, 5. Okay, did a little bit of that last week. Did a lot of that in Algebra 2. Just some reminder stuff on it today. Everybody good with finding the vertex? Now, that same parabola, how would that open? If we describe parabolas as open up or down, right or left, how would that parabola open?
Probably gonna open up.
Very good. Its A is a positive number. Okay, when your A is a positive number, you're always going to open up. If your A is a negative number, you're going to open down. When this changes at the end of our lesson, this will change to x equals y squared. That's when you get the sideways ones, the right or the left. Okay, we'll see that at the end of today's stuff. Everybody good here? All right, I'm going to have to stand in your way, and I'll just try to keep moving. The thing back there is not working real hot. I got f of x is equal to 2x squared minus 4x plus 1. Okay, see if you can find, it's a plus 1. See if you can find the vertex of that one real quick. Question. Okay, when you set up your x equals negative b, what would be in my b spot? Negative 4. All over 2 times, what's my a? 2. Now, a lot of y'all, well, the way I have it written there, a lot of y'all will be able to skip that. You know that negative and negative is going to be a positive, so it's fine if you go ahead and skip that. 2 times 2 is 4, so you just got 4 divided by 4, which means your x is 1. Everybody all right on that? Okay, now we're just plugging that in and solving for our y. So we'll have 2 times 1 squared minus 4 times 1 plus 1. 1 squared is 1 times 2 is 2 minus 4 plus 1. 2 minus 4? Negative 2. I thought you guys were telling me I messed up. Negative 1. Okay, everybody all right? All right, just going to add some stuff on this next one. I've got f of x is equal to x squared minus 6x plus 5. This time we're going to do the stuff that we did last week. We're going to find the vertex, the axis of symmetry, and the domain and range. Okay, and we did all that last week, so this is a little bit of a review for you on that. All right, by the vertex, we're going to start off the same way as we had been. X equals negative b over 2 times a. So my x should be 3, right? Everybody good? 3? Okay, that told me what on my list over there? X equals 3 would be which one of those? Vertex, axis of symmetry, or domain or range? Good, Caleb, that's your axis of symmetry. Remember, on an upside or a U or an upside down one, your axis of symmetry is always the X of your vertex. Okay, so we already got 25% of our answer done. Now we're going to plug that in, figure out the Y. So we'll have 3 squared minus 6 times 3 plus 5, 9 minus 18 plus 5. So our vertex would be
Negative.
3, negative 4. So far, so good? Everybody remember it? Got it? Alright, what did we say last week about domain when it's a normal U or upside down U? What will your domain on these always be?
All real numbers.
All real numbers. Very good. Negative infinity to infinity. By the way, this wasn't on my list, but which way does this open?
That's the one.
It is up. Blake's right, because my A is a positive 1, so it'll be up. Okay, the range. The range is your up and down. That's your Y. So that comes off of the Y of your vertex. So if the vertex is at 3, negative 4, and it opens up like Blake just said, it goes up forever, but it can go no lower than negative 4. Right? So your bracket with negative 4 to infinity.
You know what I'm saying? Yeah. Can you say it like that? What? Is equal to or y greater than y is
Greater than or equal to negative 4, yes.
I agree.
Yes, you can say that.
He got that from me.
Funny fellas. Alright, supposed to go over discriminant again. We did discriminant last unit. Remember discriminant? I'm just going to remind you, I'm not going to go over it a whole lot. Discriminant is the part just underneath the radical. Remember that? The quadratic formula x equals negative b plus minus squared b squared minus 4ac. It's just that part, and what the discriminant tells you is how many and what kinds of answers you're going to have. If your discriminant is a positive number, that means bigger than 0, you would have 2 real solutions. If it's less than 0, that means a negative number. When you've got a negative underneath the radical, you have 2 imaginary or non-real. If you're equal to 0, you have 1 real. Okay, what that looks like as far as a parabola, 2 real, you can see where it crosses the x-axis. 1 real, it either just sits on it, or not supposed to touch. Either just sits on it or touches it in one spot. Still didn't touch. I'm struggling. I'll pretend that touches right. Okay, and then imaginary, it never crosses the x-axis, so it'll just be somewhere that doesn't cross. Okay, everybody good on that? We did that last unit, pretty simple stuff. Alright, want to look lastly at the sideways parabolas. Okay, clue here that this one is going to open right or left is that it says x equals. Okay, got x equals y, so everything's opposite than they were the original time. Now, when we wrote vertex form for a normal parabola, our vertex was h comma k, but this stuff is different here. This is in the form, a sideways one is in the form of x equals y minus k squared plus h. Okay, so your vertex on that is still going to be hk. So that means our vertex using this here is going to be h and then k. What will my k be? -1. Because it's got the opposite sign there. Okay, and that always tricks everybody. So our vertex on that would be -1. Now, When we're in standard form, this was your vertex form of the sideways. When we're in standard form, bay squared plus by plus c, we're still going to do the negative b over 2a thing, except that's going to be what, instead of saying x equals, that's going to be what your y equals. Okay? So when we're finding the vertex of a sideways one, instead of x equals negative b over 2a, that will be what your y is equal to. Alright, so if I have, let's finish this one that we started first. Let me not get ahead of myself. If I had negative 4, negative 1, look at somewhere in that area. We already discussed it's going to open sideways because it's x equals. So what decides here if it opens right or left? Would this one go to point to the right, or would it point to the left?
It's going to point to the right because it's even.
Okay, it's going to point to the right, but not because it's even. Because my A is positive. So it's the same as a normal one. If your A is positive, it opens up. If your A is negative, it opens down. Here on sideways, if your A is positive, it's going to open to the right. So this one would look something similar to that. Okay, now, where's the axis of symmetry in this one? And it's got to be through there, right? So what value of the vertex is that on your axis of symmetry? Very good, Bailey. That's at your y equals. So on a sideways one, it's the y of your vertex that's your axis of symmetry. Okay? Now, for domain and range on this, when it was a normal u, the domain was all real numbers, infinity, negative infinity. But on this one, it's not going to keep going. This particular one does go right forever, but it does not go left forever. So the domain on this one, the farthest left it goes, it's negative 4, and then it goes to the right forever. Your range, everything just is the opposite here. Your range, that is going to keep going up slightly, and that is going to keep going down. So on sideways ones, it's the range that's negative infinity to infinity. So that's just the opposite of the upside down ones. Remember in that stuff? You got a scout. I'm going to follow you back there in that part of the brain. Okay, let's do another. Everybody got what you need here? Alright, let's look here. I got x equals negative y squared plus 2y plus 5. We're going to just tell everything we can. Vertex, axis of symmetry, domain, and range. Okay, good. Valentina's already figured out, since first off this says x equals, so it's right or left. After that, you look at the a, what's in front of your y squared, and it's a negative. So this one's going to point to the left. It'll open to the left. Okay, very good on that. So now, start finding our vertex and our axis of symmetry. Since this is a sideways parabola, it's y equals negative b over 2 times a. See how your a was negative 1 there? So that's negative by next positive. So 2 divided by 2 means your y is 1, right? Now y equals 1 is which one of these answers over here? Axis of symmetry. Good job. Very good. Okay, my vertex, I know the y, I don't know the x. So what am I going to do to figure the x? Plug it in. So I've got, now this negative, that's funny there. That means you do 1 squared and then make it the opposite. So that's negative 1 plus 2 plus 5, so 6. 6 on that, everybody good? Alright, we got our vertex, we got our axis of symmetry. We're looking at something over there, and we know it opens to the left because our A was -1. So it's going to look something similar to that. Other way. It goes to the left forever. So -infinity to 6. Good, Valentina. Everybody agree with that? Goes to the left forever and then stops there at 6. Range on this one is always good, Valentina. -infinity to positive infinity. Good deal. Now, what if I needed to get some more specific points? I just gave you a rough idea of what it would look like. What could I do if I wanted to get some more specific points on this?
You could have
Pick. If I was going to pick, normally when I do this, y'all know I pick numbers and plug it in the X. But this one is solved for X. So here I would want to pick some random Y's and plug them in, wouldn't I? Like I could plug, I already got 1, so I could plug in like 0. And that would be enough, because there's your axis of symmetry. So you just, remember how I showed you on last week to count however far it is away on one side of the axis, it's going to be that far away on the other side. So you could do that. 0, 5, so then over 5 and up 0. So then that would have to be right there as well. I didn't draw my parabola very good, but that's close. This is the one I was telling you about last week, though, that you can't just type that in your calculator. You can't just graph it in your calculator because it's solved for X. The graphing button on your calculator is Y equals. That would be a pretty hard deal to solve that for Y. It'd be much easier to maybe just find a couple points off of your table. I'm not even sure how I would start solving that for Y. Probably have to do some completing the square stuff, and wouldn't be my favorite thing to do. Alright. Everybody alright on that? Somebody asked last week about when they shrink and stretch. Oh, I think it might have been blank, I don't remember for sure. When they get narrow and wide, all that kind of stuff. We get into that a little bit tomorrow. Okay, so we'll talk about some of that. Also, some different types of graphs, like not all parabolas. Okay?
Numbers go bigger as it shrinks.
Yep. Alright, good deal.
I figured it out.